A particle moving in a circle of radius 2 meters at constant speed has a period of rotation 2 seconds. Its acceleration towards the center of the circle is. We know that we can write centripetal acceleration v omega squared r or v squared over r. Now they have given period. We know that period is 2 pi over omega. Then we can subject omega equals 2 pi over t. Then I will substitute this part to this one. Then centripetal acceleration is omega squared 4 pi squared divided by t squared into r. Now I will substitute values 4 pi squared into radius is given as 2 meters divided by time 2 seconds 2 squared 4. Then we can get 2 pi squared is the centripetal acceleration meters per square second. Fourth one is the correct answer for question. Two particles A and B are moving in a concentric circle of radius AD, RA and RB such that their period of rotation are same. The ratio centripetal acceleration of A divided by centripetal acceleration of B. There is a constant period. Therefore, we can get this relationship. Centripetal acceleration, there is a constant period, therefore it is directly proportional to radius of path. Then we can get centripetal acceleration of A divided by centripetal acceleration of B should be radius of path A divided by radius of path B. First one is the correct answer. A small mass is kept on horizontal circular table which can rotate about vertical axis passing through the center of the table. The mass starts to slip when the angular velocity of the table becomes omega. If the distance of the mass from the center of the table is doubled, the minimum angular velocity required for the mass to start to slip is. We know that when considering a rotating table, the mass will slip if the frictional force towards the center is not sufficient to maintain the circular path. Then centripetal force is F, it is frictional force. Frictional force is constant for both situations. Then I will get F equals ma towards the center, F equals m omega squared r. Now F is constant, therefore m omega squared r should be equals to same value for the second situation. M, I will consider new angular velocity for the radius 2r is omega 1. Now we can find omega 1 value. We can cancel out m and r. Omega squared divided by 2 means we have to get the square root. Omega divided by root 2 is omega 1. Then we can get first one is the correct answer. The horizontal table is rotating with a uniform angular velocity above the vertical axis passing through its center. A mass m is at rest on the table without slipping. Observer A is sitting on the table while the observer B is standing on the floor. As shown in the figure, the total horizontal force on M according to A and B. We know that according to A is rotating with the corresponding mass. Therefore, according to A, resultant force should be 0, but according to B, resultant force should be towards the center. Then answer should be 1. An object moves along a horizontal circular path on the linear surface of smooth conical shaped vessel as shown in the figure. The force of forces acting object as observed by the stationary observer is R. When considering forces relative to the stationary observer, he could observe weight of the object and reaction perpendicular to the surface. Then weight of object and reaction force normal to the surface only. Second one is the correct answer. 2. A child of mass 20 kg is sitting on a string of negligible mass. The string is attached to its pivot by 2 ropes, each of 3 meters length. The maximum speed of the child during a spin is found to be 3 meters per second, the maximum tension of each rope. We know that we can observe a maximum tension at the lowest point. Then tension at the lowest point should be 2T. We can consider tension of this one rope is T, and there is a weight mg. We can observe maximum tension at the lowest part and maximum velocity at the lowest part. We can use F equals ma towards the center. Center is in this side. Resultant force towards the center 2T minus mg equals ma. We can use A as V squared over R. Then we have to substitute values and we can find T value. 2T equals mass 20 kg, 2T minus mass 20 kg G10, again mass 20, radius of the path 3 squared divided by, velocity is 3 squared divided by radius also 3. Then we can cancel out 1, 3, 20 into 3, 60, 260 divided by 2, then tension should be 130 Newton. Answer is 1. A toy car connected to a fixed point, an elastic string as shown in the figure, travels in a horizontal circle of radius 2r. The initial unstretched length of the elastic string is r. The period of rotation of the car t. The car is then speeded up until moving in a circle with radius 3r. If the string obeys Hooke's law, the resistive forces are negligible. The new period of the motion on the car will be. We can get relationship with period. We can use F equals ma towards the center. Force is given by the tension. We can get tension is K. It is according to Hooke's law. Equals to m. We can use K value omega squared r. And we know that T equals 2 phi over omega. Then omega equals 2 phi over T. Then we can substitute Kx equals m 2 phi squared 4 phi squared divided by T squared into r. Now I will substitute corresponding algebraic symbols. K initial extension is r. Initial length of the rope is r, but they have given radius of the initial path is 2r. Therefore, initial extension increasement of length is r. M 4 phi squared, radius of the path is 2r divided by t squared. It is the first equation. Then we can use same one for the second situation. K, now radius is 3r, therefore extension is 2r, equals m 4 phi squared, radius 3r divided by, I will consider new tension as T1, new period as T1. Then we can divide these two equations. K, r cancelling, m 4 phi squared, r cancelling. Then 1 over 2 equals 2 divided by t squared. I will multiply by reciprocal of this term, T1 squared divided by 3. Then we can subject T1. T1 should be 3 divided by 4. t squared root 3 t divided by 2. Then answer should be 4. Two small objects of equal masses are attached to each other by a light string B and BC, and this system is connected to a fixed point A with another light string AB as shown in the figure. The masses are then made to move in horizontal circular path of radii r and 2r with the same angular speed, so that the speed of A, B, C are always in a straight line. If T1 and T2 are the tension of string BC and AB respectively, then we have to get the relationship. I will consider this object and this one. Tension on this object is T1. Then we can use F equals MA for the object C towards the center. F is T1, M. They have given that there is A, B, C points are in a straight line always. Therefore, we can get that same angular velocity. Omega squared, radius is 2r. Then I will use this object B, and S equals MA towards the center. Now there are two forces, T2 and T1. T1 equal and opposite action and reaction. Then we can get T2 minus T1 equals M omega squared r. Now radius is r, omega is same as the following, as the previous one. Then I will substitute T1 value to M omega squared r, this value, equals M omega squared r. Now we can get T2 is 3M omega squared r. We can divide this equation and this equation. Then T1, we have to subject T2. Then second equation divide by first one. T2 divided by T1 equals, we can cancel out M omega squared r, 3 over 2. Then T2 is 3 over 2 T1. Then answer should be 4. 5. A sphere M attached to a plate viewed in a horizontal circular at a constant speed as shown in the figure. The forces acting on sphere observed by the person who is at rest in the laboratory are best represented by. We have to consider forces. Now we know that there is a tension in this direction and weight in downward direction. There are only two real forces. Then answer is 2. A particle is moving in a circle with constant velocity v, constant speed v, as shown in the figure. The magnitude of change in velocity of particle between point P and Q is. They have given 2 points like this. This angle is 40 degrees. This vector is given as P, this one as Q. We have to find P minus Q, difference between P and Q. Then we can get P minus Q means P is in this direction, minus Q is in opposite direction, this direction. Then we can obtain P minus Q by using this vector. And we know that when considering minus Q, it is in this direction. This angle also 40 degrees because of this angle 90 and this angle 90. there is a cyclic quadrilateral. Exterior angle should be equal to interior opposite angle. It means this angle 40. Then we can get, we know that magnitude of this vector and this vector v. Then this side is v v sin 20. Same thing, this part also with sin 20. Therefore, the resultant vector of p and minus q is 2v sin 20. Then we can obtain the correct answer is third one.